In this video, I am going to show you how to find the determinant of a matrix. So first off, let's look at the 2 by 2. It's not too bad. You just cross multiply. It's A11 times A22 minus A21, A12. Before we do a definition of the determinant of a larger matrix, because it does get more complicated, we have to define this recursively. I need a couple definitions. So first off, if we have a matrix and we pick a particular element in the matrix, say I sub ij, A sub ij, the minor M sub ij is the determinant of the matrix we got when we removed the ith row and the jth column of A. The cofactor of that entry would be -1 to the I plus j times the minor. So the C part gives you this alternating depending on which row or column you are in. So looking at an example, a really gross example, let's say I want to find the minor with respect to that one. So that's 1, 2, 1, 2, 3, 4. That's position A sub 2, 4. So I'm going to find the minor of A sub 2, 4. I need to get rid of the row and the column, and my animation's messed up a little bit, but that's okay. So I got rid of the row and the column associated with position A24, and I have this new 2 by 2. To find the cofactor of A sub 2, 4, you multiply by -1 to the 2 plus 4, which is 6. So this will be positive. So whatever this determinant is, that'll be the same as the cofactor. Now I can actually define what the determinant of a matrix is. And it's going to be in terms of smaller determinants. So if A is a matrix, square matrix of order n greater than or equal to 2, then the determinant of A is the sum of the entries of the first row of A multiplied by their respective cofactors. So see here, I'm going along the first row. I've got A11, A12, A13, all the way across. Now, to get to the bottom line, to kind of cut to the chase, it doesn't really matter which row or which column you go across. It doesn't matter if you just keep track of the plus or minuses. Don't screw that up. But then you can find the determinant going across any row or any column. And sometimes it's easier to choose a row or a column than just blindly going across the first row. So let's look at an example for this. I have this matrix, and let's say I want to expand by minors, that's what this is called, expanding by minors, using this second row. So I'm going to have 11 times its cofactor, 49 times its cofactor, -47 times its cofactor. I feel like I said the wrong thing. Okay. So let's crank that out. Oh, isn't that gross? So I have 11 times -1 to this is the position 2, 1, so it's 2 plus 1. If I look at what's left over when I get rid of everything in this row and this column, I'm left with a -29, 95, -81, 91. I have that here. I'm going to have to crank out the determinant in a minute, or not. But that's what I meant by recursive. Every time you expand by a minor, you go down by one size. So this was a 3 by 3. I'm going to end up with a bunch of 2 by 2s. If I started with a 5 by 5, then the next line would be a bunch of 4 by 4s, and then 3 by 3, and then 2 by 2s. So it gets kind of snarky. So I've got -1 to the 2 plus 1. I've got this. I'm just cranking it out. The only thing I did, I think I went ahead and simplified the negatives. And at this point, you can crank this out. It's this cross that, minus that, this times minus that. I mainly want to get you the structure. The rest is more arithmetic. So let me show you where it will come in handy if you choose different rows or columns. Let's say we want to find it for this one. Clearly, I want to use this column. So if I expand by minors, I have 0 times -1 to the 1 plus 2 times its minor, 3 times -1 to the 2 plus 2 times its minor, plus 0 times -1 to the 3 plus 2 times its minor. Now notice, I don't care what that is, there's a 0. I don't care what that is, there's a 0. All that I care about is what this is in the middle. So I've got 3 times -1 to the 4, so that negative is gone. I can do the derivative of, sorry, wrong class. The determinant of this is 4 minus 5. I got a -1 here. So the determinant of this 3 by 3 is a -3. So when you are cranking out determinants, you can see that if I had a 4 by 4, I really want to choose wisely, because then I'll have a line of those, and each one of those will give me another line of 3. Choosing wisely and choosing the right row or column makes your life much more pleasant. I won't make you do a whole bunch of these. I just want you to know how to do 1 or 2. And then the rest of the time we can just say determinant of A in Maple and see what it gives us. And that's all there is to finding a determinant.